Okay, so here is the answer.
We can't see your screen.
Oh, sorry. There is the answer, and I will do one last thing down here to give you an actual number in case you need it. So the first one was 132, and this one was 2080.74. Which one?
1,600.
For which one? Okay. Everyone's on the right page, yes? No. Just in case people did. Some people did. If you didn't solve for pi, you should have one of these three blue lines. If you did solve for pi, you have that. Okay, or you could also have the square root of 850. You could have done that. It's like 26 point something. So you could have done 15 times. So the other thing you could have had there actually, guys, is you could have had this as 437.32 pi. You could have had that right there. Priyanka. I don't care. Sonia. No. I didn't ask for volume on either of these anyway. Okay. All right, everybody okay? Does anybody need either of them gone over? Going once. Going twice.
I did 437, so what you have up there.
Yeah.
Plus pi times 225. I don't know why.
225 pi plus 437 pi would have been...
That's what I did.
Yeah. Plus... You could also have had 25 plus 225 plus square root of 850. You could also have had...
I had like 662. Yeah, that's what I got.
Yeah.
Pi.
225 plus 15 times square root 850. You could also have had 662.32 pi.
Yeah.
You could have had any of those. That is all the possible answers you could have had. If you don't have one of those answers, you need to ask me right now how to do that question. Yes. All right. Is everybody okay with the net? Not that you need it, but there it is. Yes. I will get to that right now. So, the surface area of a cone is pi r squared plus pi r slant. Yes? Do you have a slant? No, because you have a radius and a height. So you have this scenario. The radius is 15, so you have this triangle. Radius is 15, height is 25. You need the slant. That's the hypotenuse. So that is the square root of 15 squared plus 25 squared, which is the square root of 850. Now the problem there is 850 doesn't have a square root. It's 437 point blah, right? So when I am doing math, I leave it as the square root of 850 because I don't want to write 437.261897 blah, 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 blah. So now I take this is S. So now I come down here, pi times r, which is 15 squared, plus pi times r, which is 15, times S, which is the root of 850. Everybody okay? That's 225 pi plus 15 root 850. 15 times the root of 850 times pi. Yes? I am recording this. Now, you could add this up to get 225 plus 15 times the root of 850 all times pi. When you add those up, if you do the root of 850 on your calculator, multiply it by 15 and add 225 to it, you get 662 and a bunch of decimals. 0.32 pi. Now, if you go one step further, and some of you insist on going one step further, and that's okay, you would do whatever your decimal is on your calculator, which right now is 662.3213921, then you would push times pi to get 2080.74402. That's the furthest you could take it. Any of this, that are all right. So please stop worrying about what your answer looks like. I cannot get this out enough times. Your answer is the least important piece of writing you do on every assignment. Your work is what matters. Does everybody understand me? So chill out about whether or not you've got the right decimal or whether or not you've put the X in the right spot. Okay? Show me work. Your thought process is where math happens. Your math happens in here, not in here and not on the paper. Math is done in your head. You have been trained to use this and your answers as a crutch. Don't. Okay? Everybody cool? All right. And the sphere is 2,500 pi. If you went one step further, it's 7,853.98. Does anybody need to see any more of that? Why can't you draw a net of a sphere? Because it doesn't exist. Cool? All right. The triangular pyramid. Now, this was a tricky question because many kids in my other block did not understand what the question meant. Okay? A triangular pyramid with a base of 13 centimeters. If the base of the pyramid is 13 centimeters, that means no matter what side you're looking at, it's 13 centimeters. So the base of the pyramid had to be an equilateral triangle of 13 centimeters each. How do you find the area of an equilateral triangle? You have to split it in half and do Pythagoras. You know that's 13, you know that's 6.5, so you do Pythagoras to get the height. Once you get the height, you got it to be 11.2, right? Now the area of every pyramid is the area of the base times the height divided by 3. So the area of the base, since it's a triangle, is base times height divided by 2. The base is 13, the height is 11.2. Then divide it by 2, multiply by the height, which was 9, and divide that whole answer by 3. Now I can show you that here. That is area of the base is 13 times the height, which was 11.2, all that divided by 2, times 9, because that's the height of the whole pyramid, right there. And then since it's a pyramid, I got to divide by 3. And that will get me 219.54. Cool? All right. Second one, significantly easier because it's a square pyramid. So the bottom is 4 by 4. So the area of the base is 4 squared. The height is 15. Divided all by 3. 80. Cool? Because 16 times 15 is 240. 240 divided by 3 is 80. Gouda?
Wait, how can you get 6.5?
Because that's half the bottom. Because I cut it in half to make a 90-degree triangle. You understand?
Kind of, not really.
Okay. Because it's a triangular pyramid, and because the base of the pyramid is 13. Okay?
I know why you got 6.5, but like.
There's the triangle, yes?
Yeah.
Right? That's the bottom of the pyramid as I'm looking down on it from the roof, yeah? So since the base is 13, if I am standing on any side, all the bases have to be 13, yes? So this is 13, this is 13, this is 13, right? Now to find the area of this, the area of a triangle is base times height divided by 2, correct? Okay. Well, the base is 13, but I don't know the height, do I, Max?
Isn't it 9?
No, that's the height of the pyramid. That's not the height of the base triangle. Understand? You got it? Do you understand, Max?
So the height would be 6.5?
See, again, no. Are you okay, Jenna? I hate when that happens. The only thing worse when they fly in your mouth and you're like, oh, it's too deep to spit out and you got to swallow it. Hey, you guys laugh, but sometime in your life, insects are going to be your number one source of protein. You're laughing, but it's going to happen. The world can't support animals the way we do for eating. Anyway, Max, look. You're falling into the trap of thinking of height as height. Okay? It's not. Height is simply a word we use to differentiate between other measurements. Okay? Look, this rectangle standing this way has a base and a height because it goes up and down. But if I lie it flat, it's now got a length and a width. Understand? A pyramid has a height. Pretend my head is attached to the roof of the pyramid, right? To build the pyramid, think of a circus tent. To build a tent, I have to put a pole in the middle, yes? That gives me a height, yeah? But the bottom, this is the floor, okay? The floor is a triangle. Now, the area of a triangle is base times height divided by 2. But we only say it's base times height because if I make this a triangle, right? Now I lay it down here, it's not base and height anymore, it's length and width. So a triangle, this is the bottom of the tent, of the pyramid. But since it's a triangle, I need this distance to get the area. And we have named that distance height, even though it's lying on the ground. This is the base. A triangle is base times height divided by 2. You have a base of 13, but you don't know a height. But this makes a 90-degree triangle, doesn't it? The hypotenuse is 13, and this is now half of 13. So it's 6.5, yes? Now I use Pythagoras to find this height, which ends up being 11.2 blah. So the area of the base of the whole shape is 13 times 11.2 divided by 2. That gives me this base. Understand?
Yeah.
Then I multiply that by the height of 9, but then because it's a pyramid, I have to divide it by 3 because I'm looking for volume. Cool?
Yeah.
You got it now? All right. Everyone was okay with 80?
Yep. I just did 16 times 5.
Yeah, that's fine because 15 divided by 3. You could have also done 16 divided by 3 times 15. And again, that's not your guys' fault. We have lowered the value that is placed on numeracy in elementary and middle school. So the fact that you could have done 16 divided by 3 times 15, or 15 divided by 3 times 16, or 16 times 15 divided by 3. Those are all the same thing. Somebody my age sees that automatically. Did we finish? Yes, 80. Okay. And here are the next ones. If you took these one step further, as some of you did, this was 24,429.02. And this was 7,853.98 if you went one step further. Huh? Everybody cool with them? Those are just formula ones, right? There's no trick there. Now on 37, we get into the tricks. Now this is where it's so important to show work. If you show work, you can't screw this up. The surface area of this is a rectangular prism, yes, plus the sides of the cylinder, because I'm adding that in, yes. But since I cut out this circle, I'm losing both of those circles. Everybody understand? Everybody get it? So I do the area of the prism right there. That's normal. Follow the formula. And I add only the sides of the cylinder, 2 pi RH. Because the cylinder is 2 pi r squared, that covers the circles, and 2 pi RH covers the side. So I add the 2 pi RH, but I have to remove the 2 circles because they're cut out of the top. Does everybody understand? Now somebody always says, Mr. Myers, how are you adding this side in here when you're removing it from the prism? You're not. Surface area is only on the outside, isn't it? So in this original calculation, you are not touching any amount of space inside. Got it? So then you get to here. If you have that, I'm happy. If you went one step further, that is the surface area. Does anybody need to see that gone through in greater detail?
I just have a question. So say if this wasn't, if this was a rectangular prism, but it had 2 triangles, like a triangular cylinder or whatever.
A triangular prism cut out of it?
Yeah.
Yes.
Would you find the surface area? Would you find the surface area of the whole rectangular prism and then subtract?
You would subtract the two triangles, and add the 3 rectangles because you have made a new surface.
Okay.
Do you understand?
Yeah.
Okay. And then volume is significantly easier. It's the volume of the prism minus the whole cylinder because you've cut it out of the middle. So it's just the 2 formulas. So either you have it there written out as pi or there written out as a number. Everybody okay? Jenna, go back to the last page. I can, but so can you because it's all on YouTube. Okay. Next is the cone that's been cut off, yes? So again, the surface area, if the cone were complete, it would be the large cone, yes? But I have removed the top of a small cone, but I have added this circle, yes? So I do the surface area of the big cone right there. Pi r squared, pi r slant. There it is. I take away the pi r slant of the little cone, but I still have to add the pi r squared of the little cone because I added it right there. Everybody understand? Again, it's not complicated math. You're just using the formulas. You just got to know what's happening. And the answer you end up with is 210 pi or 659.73. Volume, again, is easier. Large cone minus small cone. You just do the formula twice. Pi r squared h minus pi r squared h, all divided by 3, and you get 312 pi, which is right there. Any questions with that? We are good? Sweet. Cylinders cut in half. So the surface area is the surface area of a cylinder cut in half plus this rectangle. Yes? Because that's a new surface. So I did the whole surface area, 2 pi r squared plus 2 pi r h divided by 2. So I canceled all the 2's. Pi r squared plus pi r h plus the rectangle, which was length times width. And you end up with 160 pi plus 192, or that. Volume, again, is easier. You just cut it in half. 384 pi, or 1206.37. Any questions? Again, the mistakes you guys usually make with this isn't in the computation. It's in setting it up, right? Because you have to slow down and think about it. It's not just cut in half for surface area because you're making new surfaces. Okay? A hemisphere of 18. Remember, we actually did hemisphere in our notes. Surface area of a hemisphere is 3 pi r squared. Volume of a hemisphere is 4 pi r cubed divided by 6. You had formulas for both of them, so you just fill them in. There it is with pi. There it is with pi. There it is with numbers. There it is with numbers. Everyone okay? Which are you not okay with?
The surface area, could you go over the surface area?
All right. Surface area of a sphere is 4 pi r squared, yes?
Yeah.
Okay. If I cut a sphere in half, I'm going to divide that by 2, right? To get 2 pi r squared, yes? Except, what is this right here? A new circle. What is the area of a circle? Plus pi r squared, yes? The r's are the same. 2 pi r squareds and 1 more pi r squared is 3 pi r squareds.
So you're never, when it's like half a cylinder or half a sphere, you're never just like cutting it in half?
Only for volume.
Okay. But you always have to add the new surface?
You got to add new surfaces to surface area because you are making a new surface.
Yeah.
And surface area is measuring all the surfaces. Okay? Just like if you cut me in half, all my blood and guts down the middle is a new surface. And if you wanted to encase that surface in skin, I would need new skin to cover that, wouldn't I? Because the skin that you cut in half right here is not going to help. Okay? When you cut open a block of cheese through the plastic, those 2 open parts now need plastic to cover them, or you're going to end up with hard cheese. And who wants hard cheese? Nobody. Some crazy people don't even like soft cheese, which is nutty. Cheese is awesome. Any of you don't like cheese? Good. I'm glad you're with me on that. And finally, the grain silo is a hemisphere on top of a cylinder. And I only cared about volume. So it's volume of a hemisphere plus volume of a cylinder, right? Volume of a cylinder is pi r squared h. Volume of a hemisphere is 4 pi r cubed divided by 6. Why is it divided by 6? Because the volume of a sphere is 4 pi r cubed over 3, right? But a half a sphere, I would multiply that by 1/2. 4 pi r cubed times 1 is 4 pi r cubed. 3 times 2 is 6. Okay? Now, I cannot stress this enough, ladies and gentlemen. I give you notes for a reason. If you turn back a page in your book, what will you find? Those two formulas. And this drawing showing you how we got them. A scant 2 pages back. All right? And anyway, you do the work and you get 99 pi. Or 311.02. Now, how many of you recognized that this was a problem? Good. This diagram is not real life. It is not to scale. The pool actually looks like this. 1. That's what the pool really looks like. This side is 8. This is 15. So if I cut this here, I get 1 and 7, yes? And it's a prism, so it repeats backwards 6 times. Now, a great many of you probably found this volume, and then you found this volume, and then added it. That works, but it's a lot of extra work. If you went to your data booklet, or you remembered the million times I've said it, every prism, regardless of shapes, volume, is the area of the base times the height. Base area is not the bottom, it's the shape that repeats. Height is not the height, it is the amount of repetitions. So if I found this whole area and repeated it 6 times, I would be in business. This area is 15 by 1, which is 15. This area is a triangle, 7 by 15, which is 105. Triangle divided by 2 is 52.5, which means this whole blue area is 67.5. Yes? That's the area of the base because that is the shape that repeats. How many times does it repeat? 6. To get a volume in the pool of 405 meters cubed. Is the pool going to be filled to the brim? No, it is filled 85% to capacity. So it is 405 times 0.85, which is 300 and something? 344.25, right? So that is how many meters I must fill the pool. Now, the tap fills the pool at 1.8 meters cubed per hour. So what do I need to do with that? Divide by what? 1.8. So how long will it take? Whatever that is. 344.25 divided by 8. 43 hours. No, that's not right. Yeah. No, 344.25 divided by 1.8. Yeah, there we go, 191 hours. Now, see guys, somehow, I don't even know what button I pushed on here to give me 44. But as soon as I saw it, did I write it down? No, because I know it made no sense. Right? I did not say, 44, my calculator said so. It made no sense, so I double checked. Now, next question. 1 liter equals 1,000 centimeters cubed. How many liters will be going into the pool? What do I have to do with 344.25 to get it into liters? I want liters, right? So what goes on the top of my fraction? One liter equals 1,000 centimeters, yeah? I have meters. I want centimeters. So what do I have to do? Times it by 100? That's in a straight line, isn't it? So what do I need to times by? If 1 liter is 1,000 centimeters cubed, okay, 1 meter by 1 meter is what? That's 1 meter cubed, right? Right? But I don't want meters cubed, I want centimeters cubed. So what do I have to do with all these ones to get the centimeters? Max just told us. How do you go from meters to centimeters, guys? Multiply by 100. So what are all of these? Instead of being 1 meter, what are they in centimeters? 100, correct? So 1 meter cubed is how many centimeters cubed? 100 times 100 times 100. Yes? So 1 meter cubed is, what's 100 times 100 times 100? 1,000,000 centimeters cubed. So what do I have to do to 3425 to get to centimeters cubed first? Times what? How many of you times 100? How many of you had no idea how to do B? Okay. Well, I need liters in centimeters. Liters and centimeters is an easy conversion, isn't it? But I don't have centimeters cubed. I have meters cubed. So I have to convert that first. So I got to multiply this by 1,000,000. How many decimal places do I move it when I have 1,000,000? Somebody knows that one. 6. So 1, 2, 3, 4, 5, 6. What goes in the holes? Zeros. So it's 344,250,000 centimeters cubed. Now, 1 liter is 1,000 of those. So what do I have to do with this? Divide by 1,000. What do I do with the 3 zeros? Cancel. So I need 344,250 liters. There's more than one way to do it. But this is the way I like because it shows me everything that you know. Okay? Now again, I remind you, people do fill up pools. Somebody is in charge of filling up the pool at MRC. They need to know how much water is going into it. These are real-life questions, even though they don't seem to be real-life questions. The next question is not a real-life question. The next question is my favorite question in all of this whole unit. And it's 10:52, so I'm stopping. And we'll finish that tomorrow. I will warn you, your first instinct for number 2 is wrong.
Why do you do this?
You were supposed to finish problems and applications. If you're already finished it, you've got no homework tonight. Except that you have a small quiz tomorrow.
Is this part of formula about
Which? What about them?
Are they on here?
No.
So,
That's why I showed you how to figure them out. A sphere is on there, I think.
we have to memorize these.
No, you just have to know how to build it from the formulas that are there. Yep, they're there.
Okay.
All you got to do is know how to build it.
The hemisphere just after. I got this.
I know you do.